Lesson revolves around the idea of reflections. We're talking about this in a transformations unit, so it's going to be kind of an interesting idea. By the end of this lesson, hopefully you'll be able to reflect a figure in any given line. Hopefully that'll give you nice lines. We'll see how that turns out. Basic idea with a reflection is if something is on your line, it's going to be its own reflection. Otherwise, the idea is you figure out how far it is, the perpendicular distance to the line, then you go that exact same distance, a perpendicular distance, and make a point there. That will be the image of your pre-image. That's basically the idea. When we work with this with a coordinate plane, the same concept holds, that if we're going to reflect this over the x-axis, we first identify the x-axis, which is right here. Then what we do is we figure out how far it is. This point C is 4 units from the x-axis, so we go 4 additional units, and we call that C prime. D is 2 units to the line, so we go additional 2 units, that becomes D prime. A is 3 units to the line, so we go 3 units more this way, that's A prime. B is 5 units, so we go 5 additional units, this becomes B prime. All we do then is we connect our dots, something like this. This is very tough to do, and we have our image. Same concept works with the y-axis. Every so often you'll notice that things will overlap. That's what's going on right here. There'll be some overlap. What happens with the line x equals -2? Well, first you have to identify where x equals -2 is at. That's this line right here. Generally speaking, when you draw this in, you'll draw it with a dotted line. Unless it's on an axis like this, then you kind of make it sort of a bold line. This is the line x equals -2. One way to remember that is if you were to identify any of the points x, y, all the x coordinates are going to be -2. So this is like -2,1, -2,2, -2,3, -2,4, etc. All the points on that line will start off with a -2. Same concept then, we just say, well, how far is D from the line? Well, it's 1 unit, so we'll put 1 unit over here and we'll call it D prime. C is how many units? Well, it's 1 unit, but it goes the other way. We'll call this C prime. B over here is 1, 2, 3 units, so we go 1, 2, 3 units past the line this way. This is B prime. E is E is only 1 unit, so E prime is only 1 unit away. E prime. A, we go 1, 2, 3, 4 units. 1, 2, 3, 4 more units. That's going to be A prime. And we just connect the points, A to B to C to D to E, and then back to A, and there's our image. Kind of a tougher concept is when that line is y equals the -x. If you think about this as being y equals mx plus b, we would know that our slope is -1 and our y-intercept is 0, our b is 0. That's going to go through this point, 0, and have a slope of -1, so it's going to go right along this path right here. It'll continue going up this way. Something like this is our line, y equals -x. E is on the line, so E and E prime are the same. Same thing with J. J and J prime are both on the line. When we do these next ones, it's a little bit different. Instead of being sort of to the line and then through the line in the same direction, it's a little bit different when we have this diagonal line, or this line that's slanted at a 45-degree angle, something like this. What we'll do is we'll actually go up 1, 2, 3. We'll actually go out or bounce in the exact opposite direction, not the opposite direction, a 90-degree angle of there across the line. So the idea is we go up 3, we'll go right 3 across the line, we'll sort of bounce. So we'll hit and we'll bounce. G, we go up 1, 2, 3, 4, 5. So we'll go out 1, 2, 3, 4, 5. This is G prime. H prime, it doesn't matter if you go up or go over, so I'll just go over 1, 2, 3, 4, 5, and we go up 1, 2, 3, 4, 5. It just has to be a 90-degree angle with what you're working on. The last one is I. I'll go up 1, 2, 3, 1, 2, 3 at a 90-degree angle. There's I prime. I then connect my points, J to I to H to G to F to back to E. Looks like this. Maybe like some sort of monster here. I'm not sure what this is, but it is a reflection over this line. If you were to slant the whole paper, just like a little bit that direction, this would go down right in the middle, and you can kind of tell pretty easily that's what's going on. Maybe like a little bit of a heart. I'm not sure what that looks like. The next thing we're going to work on is we're going to do the exact same thing, only without any help of the axes. So we're going to find the coordinates without a coordinate plane. So here's the idea, is that if we have the point M, it's going to become M prime. And if we're going to reflect over the line y equals 1, the idea with that is that your x coordinate is going to stay the same. Since you're going with y is a horizontal line, your x coordinate stays the same, your y is what's going to change. So this is 3. Since this is 1, we say how far is it from 4 to 1? Well, I have to subtract 3. So once I'm there, I have subtracted 3. I'll subtract 3 more to get to -2, and that'll be my point. Very similarly with n prime, since it's the line y equals -1, our x stays the same. How do you get from 2 to -1? Well, that's subtracting 3, so we'll subtract 3 more. This will give us -4. With p prime, we're reflecting over the line x equals -3, so our y's will now stay the same. How do you get from -2 to -3? You subtract 1, so we'll subtract 1 more. That'll give us -4. With q prime, let's see, it's at x equals 3, so our y will stay the same. How do you get from 5 to 3? You subtract 2, so we'll subtract 2 more through the line. Next, there are some rules, mathematical rules to talk about reflections whenever you reflect over your x-axis. If your point was AB, notice that your x coordinate stays the same, but your y coordinate is now the opposite. If you start off with a point AB and you're going over the y-axis, your y coordinate stays the same, but your x is the opposite. Reflecting over the line y equals x, you'll switch, you'll sort of flip-flop your A and the B. You're reflecting over the line y equals -x, you flip-flop them, and you negate each one of them. So if it was positive, it's negative. If it's negative, it becomes positive. It's just the idea of a reflection. The idea here is that it is an isometry, so when you reflect it over, this triangle is the same as this triangle. They are congruent triangles. Use a diagram to name the image of segment 1. This is kind of fun. Why don't you pause the recording this time, and we'll talk about it in just a minute. Okay, hopefully you've gotten some results here. A reflection in the x-axis, if we are reflecting this, we'll just get line 7, so that'll be down here. A reflection in the y-axis, that'll just give us the line number 2. Reflection y equals x, that's this line right here. That means we'll reflect over. That should give us 4. Reflection of the line y equals -x, that's this line right here, kind of if 5 was extended. That means we're just going to kind of fold 1 over on top of itself, and you'll get 1 back. Reflection in the y-axis, again, that gives us 2, and then followed by a reflection in the x-axis that would flip down here. So we start off with 2, and finally we end with 4. So 4 is really the final answer there. Then we reflect in the x-axis, so that reflects down and gives us 7. Then when we reflect over the y-axis, that'll again give us 4 as our final answer. Those are kind of fun. Hopefully you were able to do those without too much trouble. These next problems are a little bit different. They're finding the minimum distance. In your textbook, it kind of just talked about how to do this in general. They don't really tell you how to do this on graphs. So here are some instructions, and I'm not sure how much they really make sense. I tried to write them out. They do make sense once you know how to do it, but if you don't know how to do this, I don't know how much this makes sense. It says find the point C on the x-axis so that AC plus BC is the minimum. I'll give you some sort of scenario here in a little while, but the idea here is that we're going to find that we're going to reflect over the x-axis. So again, here's the x-axis. Good idea to be able to identify that. We'll identify both these points over 3 up 2. Looks like this. B is -3 up 4, so that's this guy right here. This is B. What we're going to do is we're going to reflect either one of these points over our axis. Since A is closer, I'll just reflect A. You could easily just pick B as well. This becomes A prime. It's over here. Now what we're going to do is we're going to try to find some point C so that, you know, if we put C right here, these two distances added together would be minimum. Well, if these points were exactly the same distance from the x-axis, you'd put it right in the middle. We got to figure out kind of a different method for this. So once we've reflected this over, What we'll do is we'll quickly draw a line. Let me see if I can draw a line sort of using some of these line tools. We'll draw this line from B to A, just like so. And wherever that intersects our axis, wherever that intersects at, which is right here, that's going to be where we're going to put C. So wherever this line from B to A prime intersects our reflected, our line of reflection, that's where you're going to put C. So what happens is AC plus BC is going to be at the minimum when it's right there. If we put it right here, you know, from B to C might be shorter, but then from A to C is a little bit longer, which makes the addition a little bit different. Let's try 15 really quickly. I'm going to change this from the x-axis in this case. We're going to try this as the y-axis. We'll do the same thing just so you have an exposure to both of them. Again, we'll plot the points. We're going to be over 10 up to, I really hope I plot the points correctly. If not, just kind of go with me on it. 17, 5, here's 5. 17 is going to be, let's see, that'd be 18, so 17's halfway through. There's B prime. I'm sorry, that's just B. Let me get rid of that B prime. Just B. Okay, what I'm going to do is I'm actually going to reflect. It doesn't matter which one I reflect. I'm reflecting over, I guess, the y-axis this time. So what I'm going to do is I'm just going to reflect B over just to show you that it could be either point. It doesn't make a whole lot of difference. Here's 16, here's 18, and I'll go up 5, which should be right here. That's B prime. Then again, I'm going to draw a line. If I can remember how to draw a line here, that's not a line tool. Here's a line tool. From B prime to A looks kind of like, oh boy, that's really hard to do. Oh, how about that? Right there. Okay, that's not exactly a really good point, but we got the idea. And this is going to intersect right here at over 0 up 3. That's going to be our point C. So what we've done is we've minimized, oh, that's not a very good line either. I really have to work on this. We've minimized these two distances by placing C right here. Now what happens if that's not a really nice point? What if that's somewhere between 3 and 4? Sometimes this kind of becomes sort of a guess method, and that's not really a nice way to do it. There is another way where you need to write the equation of the line, which I think is a really slick thing. If you can figure out where this point is without too much trouble, you can actually find the equation of the line A, B prime by finding the slope, and then between those 2 points you can substitute one in and actually find the y-intercept. That y-intercept of 0, 3 is actually the point that will help minimize what's going on. In this case, we would find the slope of the line from B to A prime. Then we'd find the y-intercept is this point. We'd actually have to substitute, we'd actually just set the, since this is the x-axis, we would set y equal to 0, and we would find that this is going to be over 1 up 0 when we set our y equal to 0. A little bit more complicated to do it that way, but it does give you the exact answer if there's going to be some sort of decimal or something else. What we're going to look at next is just composition reflections. These aren't all that complicated. The idea is you're just going to do the same thing twice. I'm just going to talk about this. The reflection in the triangle ABC these are the vertices right here. We're going to reflect triangle ABC in the first line. Then we're going to reflect the new triangle, the image, over in the second line, and we're going to get what is called A double prime, B double prime, C double prime. So the first thing we'll do is we'll just like plot these points. We're actually reflected over the line y equals 4. So y equals 4 is up here, so we would reflect it once, and then once we have that, we'll actually reflect it over the line x equals -1. So there'll actually be 3 different triangles here. Not too tough, it just kind of takes a little bit of time. The next thing we're looking at is the reflection matrix. So this kind of puts together the idea of matrices as well as reflections, which is kind of neat. I definitely did not have this when I was in high school, so this is kind of a cool thing to be doing now. It says you can find the image of a polygon reflected in the x or y axis using matrix multiplication. There's a specific matrix that we'll have when doing these reflections. Write the reflection matrix to the left of your polygon matrix, then multiply. Notice that because matrix multiplication is not commutative, this is something we discovered in a previous lesson, the order of your matrices, the product, is important. So the reflection matrix always has to be first, and your polygon matrix is second. So here's the idea. These are reflection matrices. We'll always put these first, either one of these, depending on which one we're multiplying by, followed by what's called a polygon matrix, which we'll show right here. The vertices of triangle PQR are PQ and R. Find the reflection of PQR in the x-axis, and then graph it. We're probably not going to graph it, but I'll show you how to do this really quickly. Multiply the triangular matrix by the matrix of reflection in the x-axis. So first we write down our matrix of reflection, our reflection matrix. Oops, that's not it. That's 1, 0, 0, negative 1. Then we'll write down our polygon matrix. Remember, you get that by writing out basically the x and y coordinates of our p, q, and r. So that'd be negative 3, 6. That'd be negative 5, 3. That'd be negative 1, 2. And then all of a sudden we go through and we multiply these. When you multiply this would be a 2 by 2 times a 2 by 3. We should get back a 2 by 3. It should look very similar to this. And it'll just kind of tell us this will be kind of P prime, Q prime, and R prime is what that's going to look like. Those will be the coordinates. So that's where we're at. Why don't you guys take just a second? Why don't you guys multiply this, and I'll show you the results here in just a second. Why don't you pause and multiply? All right, welcome back. When you multiply this, hopefully you notice that each of the x coordinates stayed exactly the same, which makes sense if we're reflecting over the x-axis. The x coordinates will stay the same. And our y coordinates all became the opposite. So the opposite of 6 is negative 6, the opposite of 3 is negative 3, and the opposite of 2 is negative 2. This should be expected, but it is integrating the idea of matrix multiplication in with what we're working on now, reflections. Last thing, since the line y equals, I like to think of this as a fraction, 1/2 x minus 4 is reflected in the line y equals negative 2. What is the equation of the image? First thing I'm going to do is I'm going to graph this line. It says a y-intercept of negative 4, which is down here. And then we have a slope of up 1 over 2, up 1 over 2, up 1 over 2, like so. And I'll just continue plotting these points here to the left as well. This creates our line. Let me quickly try to draw a line. This is kind of embarrassing. It takes so long for me to draw this line. Looks something like this. Okay. Then we go through. We're going to then reflect this in the line y equals negative 2. Actually, I could have used that line tool again. If I can find it. Come here, line tool. We'll use dotted lines. Line y equals negative 2 is going to look something like this. So then what we're thinking is we're just thinking, well, okay, we have these points. If I'm going to reflect over this, it's 1 point away, so I'll put another point here. This is on the line, so that's our point. This one is up here. It's about 1 point away, so that's right there. This guy's maybe like 1, 2. So this guy's going to be 1, 2. That's going to be up here. This guy is 1, 2, 3 away, so 1, 2, 3 away looks like this. And you can kind of see this line being formed as we're moving along. So if I was to draw my own line in here, it would go like this and it would continue. Okay, come on. Oh, maybe not that far. Something, come on. Something like this would be what our line is. Okay, having a hard time placing the line. It's going to look, oh boy, come on. I'm just going to leave it alone. That's pretty close to where it is, but not exactly. So we have to figure out what the equation of this line is. It would go through this point. So if we were to write in y equals mx plus b form, our b is going to be 0 right there. It's going to go through that point 0, 0 right there if I would have placed it correctly. And our slope, it looks like we're going down 1 and over 2, down 1 over 2, down 1 over 2 as we go along. So it gives us a slope of negative 1/2 x. So our equation is just going to be y equals negative 1/2 x. We don't write the plus 0. Hopefully you learned that before in algebra. That's just the idea with this. So this is a way that we can reflect a line over another line. We've talked about how to reflect a triangle using a reflection matrix. We could probably apply the same concepts with a quadrilateral or more polygons. We talked about how to do multiple reflections. So the idea is if we started with ABC, we would get A prime, B prime, C prime. And if we reflect this again, we'd get A double prime, B double prime, C double prime. We talked about how to minimize the distance by finding a point C, which what that does, it doesn't necessarily have a reflection, but it uses the idea of a reflection in order to find it. Before that, we actually found reflections, just sort of what does the reflection look like. We talked about basic rules behind reflections, which are pretty useful. We actually found the coordinates of a reflection without using a coordinate plane. We did it with a coordinate plane as well. So there's a lot of things that we did. I knew it took 20 minutes to get through this lesson. Lots of interesting things that we can do with reflections.